Okay, here we are back with the module 2 of the math. Remember the SAT is computer adaptive now, which means it gets harder the better you do. So this second module should be pretty difficult based on how we did on the first, but let's see. Here we go. Let me make sure I share my screen for you guys. Sorry about that. All right, here we go. Module 2. It looks like we probably had about 35 minutes to do this. Expression is equivalent to this. You're just going to add these two like terms right here. So that's this one. You just divide these right here. It looks like I would guess like 92%, but if you want to be careful here, you could do 828 divided by 900, which is 92%. You see that right there. This one I would just work this out using your basic algebra. You want to be decent at basic algebra. So if I distribute this 2, I get 6t minus 20 plus t equals 40 plus 4t. That's a 40, not a 46, and that's a plus. Now I just need to combine like terms. 6t plus t is 7t, and I'm going to minus this 4t across. So that's 3t. So I just combine this term, and this term. Remember this one, because it's switching equal sign, becomes a minus. Then I'm going to plus that 20 over to the other side, and I'm going to get 60. Be careful here. You always want to read the question. The question says, what is 3t? So don't go solve for t right now. I'm tempted to divide by 3, but I don't want to do that because I've already got the answer. 3t is 60. X plus 4. Okay, so this is like a unique problem here. You can distribute these, the 5 and the 4, but it's easier if you think of this whole x plus 4 as a single thing. And I've got 5 of these x plus 4s over here and 4 of them over here. So I'm going to minus that to the other side. And x plus 4, 5 minus 4, x plus 4 is just 1 x plus 4, and that just equals 29. So it's right there, much quicker and easier if I don't distribute. But you certainly could get the answer by solving for x. Distribute, combine like terms like we did on the last problem, solve for x, and then add 4 to it. But if I forget to add 4, I'd end up down here with that 25. So just be careful. Neighborhood consists of a 2-hectare park and a 35-hectare residential area. The total number of trees in the neighborhood is this number right here. The equation 2x represents this situation, which is the interpretation of x. So x goes with the park. So I would say it's like something like the number of trees in the park, or the number of trees per acre in the park. Number of trees per acre, hectare in the park. Average number of trees per hectare in the resident. It has not got anything to do with the residential area, because remember the 2, the x goes with the 2, and the 2 is with the park. So you kind of tempted between A and C, but the total number of trees would be what you would get after you multiplied by 2. So it would be A. A certain rectangular region of a ratio, the ratio of its length to its width is 35 to 10th. That the width of the rectangle increases by 7 units. How must the length change to maintain this ratio? Oh, interesting. I believe this could be done as a proportion. Wait, 35 to 10. So I've got a ratio 35 to 10. So if I'm increasing this by 7, if I'm increasing the width by 7, it's going to 42. If this is 35 units to 10 units. And to maintain that same ratio, this ratio right now, by the way, is, if I simplified it down, divided both of these by 5, I've got a 7 to 2 ratio. So 42, 6 times 7, I guess, is 42. So 6 times 2 is 12. Let's decrease by 7 units. Oh, I read that backwards, sorry. The length to the width is 35 to 10. So the 10 is the one that changes. The width increases by 7. This one's going up to 17, and then you're trying to maintain, how must the length change to maintain this ratio? And I think this, so it's got to increase, and it's got to increase by more than 7. So I would just go with this one, and I wouldn't even bother figuring out the math behind it. But I bet you could set up, if you needed to do it, it's probably like a proportion kind of thing. I'm not sure if this would work, but I don't need to figure out if that would work. It's got to be this one, because it's got to increase, and it's got to go up by more than 7, because 35 is bigger than 10. So this is one, you're just solving for n here. We've just got to solve for n. So first thing I'd probably do is minus the 9 over to the other side. Now interestingly here, I've got this n on the bottom, but what I can do is I can essentially swap this with this. I'm multiplying the n to this side, and I'm going to divide this whole p minus 9 to that side. So I'm going to get n equals 14, and I'm not even looking at the answer choices right now, p minus 9. Now I'm going to see if that's an answer choice. If not, then I'm going to have to go figure out something else. It is. There it is, D. So I'm going to go ahead and grab D. So when something says it's equivalent to, that immediately tells me that I can set those two things equal. 24 over 6x plus 42 equals 4 over x plus b. Okay, I haven't even read the question yet, but that's what that means. Where b is a constant and x is greater. What is b? So now I just got to solve for b. I think the trick here is, here's the trick. This is a tricky problem, but if I make these ratios the same, if I multiply this one by 6, top and bottom, 4 times 6 is 24. And now I've made these two top parts equal, and the bottom parts are going to be equal too. The bottom now is going to be 6x plus 6b. Okay, so you can see the 24s line up, the 6s line up, and the 6b then equals 42. And if 6b equals 42, then b is 7. Circle A in the plane has this equation here. Circle B has the same center as A. That means the first part's going to be the same. The radius of B is 2 times the radius of A. What is K? So remember, this number is the radius squared. So radius for A is 2. That's the radius of A. So the radius of B is 4. But this K is this second, we'll call this R2. Actually, let's call it, this is the radius of A, this is the radius of B, and K is R squared, RB squared. So it's 4 squared. So this one's 16. Business owner plans to purchase the same model of chair for each of the 81 employees. The total budget is $14,000, which includes a 7% sales tax. Which of the following is close to the maximum possible price per chair before sales tax the business owner could pay based on the budget? So the trick on this one is you want to factor in this sales tax. We've got to pay 7% less. So a lot of people here would be tempted to 7% less would be tempted to multiply this 14,000 by 93%. What we actually want to do though is divide it by 107%. So I'm going to divide that 14,000 1.07. So this number here, this 13,084, that's how much money I have to spend on the chair itself. And then when I multiply that by the 7%, I'll get the 14,000. So I'm going to take that number and divide that by 81. And that will give me the 81. Oops, wait. Back. I didn't like that. So I gotta learn to use this calculator. All right. So I want to take that answer. And I want to take that, I'll just put parentheses around this and then divide that by 81. So it's 161.53. That one. Possible value for x. I would, okay, so I've got this system of equations, but it's parabolic because I've got the x squared right here. It's not a normal system. What I'm going to do is set these y's equal. So I'm going to solve both these equations for y and then set them equal. So this first one, I'm going to minus the 8x over to the other side. And the second one, I'm kind of going to flip it around. I'm going to actually minus the 341 over to the other side. 2x squared minus 341, which will leave me the positive y by itself. And then I flip that whole equation around just so that my y is on the left on both of them. Now I just want to set the whole thing equal to. So I'm going to go 2x squared minus 341 equals minus 8x minus 11. To solve a quadratic, I want to set it all equal. So over here, I'm going to go 2x squared minus plus 8x. And then I'm going to plus 11 to this 341 and get minus 330. And that's equal to 0. And then I would try and factor that. Actually, I forgot I have this Desmos calculator. I'm trying to do everything without a calculator. I think, let me see if I can just type these in. 8x plus y equals minus 11 and 2x squared equals y plus 341. Okay, now let's make this bigger and let's zoom way out and see if we can see where these two cross, because that, oh, I'm zooming in. Zoom out till you see where these cross. System of equations. So here would be one solution, and it looks like x is 11 at this point. So, and it asks for the x, the value of x. So let me make my calculator go away, or at least get smaller. Let's see, I said x was positive 11. So the negative 11 is not true. Let me go back and find the other solution, because that was one solution, but there's another solution up here where these two cross, and it's negative 15. So negative 15 is going to be the answer I think that we'll choose. That's the A right there. So yeah, ignore all this down here. On this new test with the Desmos calculator, remember you've got it and just put it in like that. Literally type in what they gave you and then look for where they cross. And it asked for the X value. If it had asked for the Y value, I would have just grabbed the second coordinate out of that pair. How many solutions does this have? It looks linear right off the bat. So there's nothing, and by that I mean there's no squared. So right off the bat, your guess on this should be 1. But it may be useful. Sometimes these things can have no solution or infinite solutions or something like that. So it might behoove us to distribute this. Let's just see. Let me clear that. So I've got 150x on this side minus 90. And then on the other side, I've got 15 times 6 is what? I don't like doing math in my head if I don't have to. So that's 90. So we've got 90 here on the other side. That's minus 15 times 6. So that's also a minus 90. And then minus 15 times 10 would be plus 150. So we have here the exact same thing on both sides. 150x minus 90, 150x minus 90, which means I can put anything I want in for x and have it be right. So my first guess was exactly 1, but it was good that we went ahead and did that extra step because it's actually infinitely many here. C is the right answer. When the quadratic is graphed, vertex is minus 3, 6. One of the intercepts, what is the other intercept? This is just something to know. The vertex of a parabola is always halfway between the two intercepts. So if one of my intercepts is, or if the vertex, the x coordinate, so let's ignore these y's, so 6 and the 0, these are all going to be irrelevant. So minus 17 over 4 minus 3 and what? How I need to figure out how far this is away. I'm going to turn this minus 3 into a minus 12 over 4. It's kind of like finding a common denominator. So I multiplied the 3 by the 3 over 1, if you will, by 4 top and bottom. So 17 to 12, that's plus 5. So I need to go plus 5 more. That's supposed to be a plus 5. 12 plus negative 12 plus 5 is negative 7 over 4. And so I need to look for that one. All right, what do we got? 17 minutes left and 14 questions. So we're doing pretty good on time. Me stopping to explain everything is slowing us down a little, but I hope you appreciate the explanations. Okay, this graph is shown. This plus 14 means this has been shifted vertically up 14. So the original graph is just 14 down from whatever this is. The slope is all the same, so I don't need to pay attention to that at all. All I need to do is pay attention to these intercepts. The intercept here is 2. So the original intercept was 14 less than 2, which is going to be minus 12. B equation have more than one real solution. Given equation B is constant for which following values of B. I wonder if we could, let's try something here. Let's try just plugging these in instead of doing this with the calculator here. Get my calculator's not working. Get it to pop back up. There we go. So I did have the calculator just glitch there. That was interesting. 64x squared plus minus 91x plus 25. What I'm looking for on the graph is I'm looking for this graph to go below. I'm looking for it to cross the axis twice. So that looks like the right answer. Let's just change this and see what happens for the rest of them. That one touches the axis only once, and I'm guessing the rest of these won't touch it at all. They'll be too high up. Oops, I don't know what that was. Plus 5. That one we can't even see, but you can see it's gonna, if I zoom out, it's probably way up there. And I'm guessing if I put 40 in, it'll go even higher up. It'll become further and further away from a real solution. So anyway, we don't have to do that. 91's right. So that one, I think the best way to do that was just plugging it in. It's not the way I would have originally done it. It's not the way I would have done it on the old paper SAT, but we need to take advantage of this Desmos calculator we've got. Again, I'm thinking we just graph. Anytime we get these graphs, let's use the calculator. So I'm going to go ahead and type in 7x plus 2y equals minus 31. It's asking me for the intercepts, x and y intercepts. So the x intercept is minus 4.429 and the y intercept is minus 15.5. So maybe there, okay, actually, so I don't like this. With those dots, you can, we're going to go old fashioned. You can always find the x-intercept by plugging 0 in for y and solving, and you can always find the y-intercept by plugging in 0 for x and solving. So if I were to do that, if I plug in 0 for y, then I've got 7x equals minus 31. So x equals minus 31 over 7. And if I plug in 0 for the x-intercept, by the same token, I've got minus 31 over 2. All right, now this thing told me that the x-intercept and the y-intercept are a and b respectively. And then it asks me for what is b over a. So it's telling me I want 31 over 2 over minus 31 over 7. We do keep, change, flip. We keep the top, change it to a multiplication problem, flip the bottom one over, keep this negative. I like to scratch out the bottom one. It's no longer there. These minuses will cancel each other. These 31s will cancel each other. And so 7 over 2 is going to be the answer here. Positive 7 over 2. T is constant, system has no solution. Okay, so when you get this no solution, it means that your x and y, your x and, they used to do this a lot on the old SAT, on the paper one that you still see these days, but the it means your x and y coefficients are proportional. So I'm going to minus this 10y over on this top equation. 4x minus 16y equals 2. And I'm going to do the same thing with the x on the bottom equation, minus 2x plus ty equals a half. Now this side becomes irrelevant at this point, and all you do is set up a proportion with the coefficients like this, and then solve that for t. So 4t equals 32. So t equals 8. Do that anytime you see that no solution, or if you see infinite solution, do the same thing. Isosceles right triangle. So that means I've got a 45, 45, 90 triangle. Because this, I got two sides that are the same, which means two angles are the same. Apologize for this horrible drawing of a triangle here, but these are two 45, 45, 90 triangles. The hypotenuse is 50, excuse me, the hypotenuse is 58. That means these two sides are 58 divided by root 2. You should just know that about your 45, 45, 90. However, it is in the reference sheet right here. The small side, the hypotenuse is the square root of 2 times the small side. If they give you the hypotenuse and you're going backwards, you just need to take that hypotenuse and divide by the square root of 2. Okay, let me get rid of the reference sheet now, though. I don't want that anymore. Go away, reference sheet. Okay. And I also want there. Okay, now it asks for the perimeter of this triangle. So the perimeter is just going to be 58 plus 58 over root 2 times 2. Something like that. Let me put this in and see what Desmos does with this and see if it gives me, if it simplifies this answer down for me. 58 plus 58 divided by square root 2 plus 58 divided by, where's the square root 2? It doesn't look like it's going to give me the answer I want. I was hoping it would simplify it like some of these other calculators do. I need the keyboard thing. Square root 2. Yeah, it's just giving me that. So I'm gonna have to do it the old-fashioned way. Let me get rid of the calculator then. 58 times 2 would be 116. So I've got 58 plus 116 over the square root of 2. To get rid of the square root of 2, I multiply by square root of 2 top and bottom. This becomes 2, so I'm actually going to end up 116 divided by 2 is back down to 58. So I'm going to go 58 square root 2. So it's 58 plus 58 square root 2. This one. For the linear function f, table shows 3 values of x. A minus b. Oh, so they want me to find both the intercept and the slope and then subtract them. The intercept is just going to be, oh, I was about to say it's 2, 0, but that would actually be the x-intercept, and I need the y-intercept. So the slope here is clearly 64, because every time it goes up 1, it goes up 64. So A is 64. B is actually going to be negative 64 minus 64. I need to go back down 1 because I want to add another point here that's like 0. If this table went back this way, 0, and it would be negative 132. I think that is 64 times 2. Is that 132? No, that's not even close. Come on, 128. Negative 128. So A minus B, this is 64 minus 128. So that's 64 plus 128, which has to be this one. All right. We are down to the last few questions. Data set consists of 10 integers. 6, 7, 8, 9. This list shows 9 of the set. So one of these is missing. Integer is greater than 42. The mean of these 9 integers is 42. If the mean of data set A is an integer that is greater than 42, what is the value of the largest integer from data set A? So if data set A is an integer that's greater than 42, then the missing value must be greater than 42. I would and they're all less than 60. So I guess what you've got to do here is figure out how high you could go. Um, okay, so I've got this whole thing, and if I divided that by 9, I should get 42. So I did it right. I just double checked I did it right. I'm now going to add plus 60 is the biggest number that I can have. I'm going to divide by 10 now, and that's not an integer. And so what I'm going to do is just kind of back these off. 59, not an integer. 58, nope. 57, no. 6, 5, 4, 3, 2. 52 is the biggest number I can do, and still have the answer be an integer. So there may be a better way to do that one. I have to think about that one. 25 museum charges 21 for the per person for the first 25 people. 40 years. So you have 21 times 25 for the first 25 people, and then after that you have $14 for each additional person or group with n people where n is greater than 25, but you need like an n minus 25 here, like that, because you've already paid for those first 25 people. So I need the calculator back for this one. Ooh, I'm running low on time. 21 times 25 is that 525. So it's probably except so I need to minus 14 times 25. And that gives me this 175. So it's A. Sorry, I got to rush a little bit, guys. Just make sure I get this last one done. Got a triangle here. L, M, N. L is 60. I also have this RST. LN is 10. RT is 30. This is also 60. So I'm trying to prove they're similar. MN is 7 and ST is 21. Yeah, if I have two sides and an angle, that would be sufficient. So I think it's going to be this one. I'm rushing though, so let me check these others. 7 and 7 would not be right. Measures of M and S are 70 and 60. No, the measure of the angles would have to be the same for it to be similar. So that would easily rule out those. That's definitely out, so it's got to be B. All right. Sweet. All right, we got a minute to spare. Hope you enjoyed that. Let's see if it gives us immediate scoring or what. Let's see what happens. I don't know what's going to happen now. View your score. Let's see how we did. Fingers crossed. How would you rate your test taking experience? I would rate it excellent. I feel like it went really well. I do think I need to get a little better with that Desmos calculator. And so all of you out there, if you're not super familiar with it, make sure you're good at that before you get on this test.